Today I will present about one of the subtopic of machine learning. It is key concept of machine learning. Key concepts in machine learning are the core ideas that explain how algorithm works, model are built and trained. The difference between supervised and unsupervised is, in supervised learning, the model learns from labeled data, while in the unsupervised learning, the model finds patterns in unlabeled data. Model evaluation checks how well the model performs after training using metrics like accuracy, precision, and recall to measure effectiveness. Overfitting happens when a model learns too much from training data and struggles with new data. Underfitting occurs when a model doesn't learn enough, missing important patterns in the data. Neural networks are models with layers of interconnected nodes. Deep learning is a type of neural network with many layers, allowing for more complex pattern recognition. So, ensemble methods. Explanation: assume you have a group of specialists who all have different perspectives on an issue. By merging both perspectives, you can achieve a better answer. For example, think of a decision tree as a flowchart. You begin at the top with a query and then follow the branch based on the response. A gradient descent is an optimization algorithm that minimizes functions like the loss function in machine learning.
Okay, so today I want to talk about the types of machine learning. There are three types to machine learning, which is supervised machine learning, unsupervised learning, and semi-supervised learning. Okay, so in supervised learning, we feed the machine training datasets and desired outputs to create an algorithm. So the machines take the algorithm as a reference and process the input raw data and give the outputs that we desire. So I would like to talk about unsupervised learning. So in unsupervised learning, we do not give the machine any training datasets for it to reference by. So they will interpret the data themselves and create an algorithm themselves. They'll process it and give their respective output data. Okay, so lastly, I want to talk about semi-supervised learning. So, in basic terms, semi-supervised learning is actually a mix between supervised and unsupervised learning. So, we use these techniques when we are dealing with data that is a little bit labeled and the rest, large portion of it is unlabeled. We can use the unsupervised techniques to predict labels and then feed these labels to supervised techniques. This technique is mostly applicable in the case of image datasets where usually all images are not labeled.
Alright, thank you Arif for your explanation on your subtopic. So we will move on to the next subtopic. So the next subtopic will be application of machine learning, and I will explain to you guys what are the application of machine learning. So firstly, we have image recognition, and it is used to identify objects, person, places, and digital image. Second, we have speech recognition. It is a process of converting voice instructions into text. And next, we have traffic prediction, like Google Maps, which shows us the correct path with the shortest route and predicts the traffic conditions. And next, we have product recommendation. It gives us recommendations about what are we looking for. And next, 5, we have self-driving cars like Tesla, BYD, and another else. And next, email spam and malware filtering. Whenever we receive a new email, it is filtered automatically as important, normal, and spam. And next, 7th point, virtual personal assistant. It helps us in finding the information using our voice instruction. And next, 8, online fraud detection. It is making our online transaction safe, secure by detecting fraud transactions. And 9, stock market trading. It is used for the prediction of stock market trends. And lastly, we have medical diagnosis. And in medical science, machine learning is used for disease diagnosis. Alright, that's all from me, and we move on to the next subtopic.
Next, I will talk about challenges in machine learning. This is an overview of machine learning challenges. Poor quality and quantity of data. Machine learning requires large dataset to learn effectively. For complex tasks like image recognition, millions of examples may be necessary to train a model to generalize well. Next, lack of training data. With a small dataset, the model cannot learn effectively because it has limited example of pattern. This results in poor generalization. Scalability. Companies like Google or Facebook deal with billions of data points from user interaction, posts, and ads. For example, ride-hailing app like Uber needs to predict estimated times of arrival (ETA) for thousands of users simultaneously. Overfitting and underfitting. Overfitting occurs when the model memorizes the specific lighting, background, or angle of the image in the training rather than learning the general feature of the object. Underfitting occurs when a machine learning model is too simple to capture the structure of the data, resulting in poor performance on the training data and the test data. Data privacy and security. In healthcare, training models on patient medical records requires access to sensitive information. Mishandling data could result in severe privacy violation. That's all. Thank you.